All right, so this is a graph function. Sketch a graph of a function that satisfies all the given conditions. I start always by searching the points I can plot, if you know what I mean, of values. Let's just plot points. And the next thing I want to do is set up a couple derivatives. So if I make this entire page and give myself a little bit of room here, I'm going to try to be a little accurate. I might have to erase and fix some things, but 0, 0 is easy, and 2, -1 is pretty easy. So there's those 2 points. And if this is my class, my test, those are 5 points each. So check, check, done. I'll do this in blue. F prime of 2 equals 0. Guys, that means that there's a horizontal tangent. That's not the blue line is not the graph, right? The blue line is the graph of the tangent line at that point. And I'm going to write a continuous function unless something changes with it, okay? So I'm picturing that slope. That would be here, all right? Now, everything else in this problem is about increasing, decreasing. So the next thing is a first order derivative. All right, and here it says from f prime of x is less than 0, which means the function is decreasing from 0 to 2. So guys, and that makes sense when you look at this, right? Because if I'm going to get from this point to this point, I have to go down. And I'm going to erase the black here in a minute, guys. Then it says what? That it's greater than 0 if x is greater than 2. So it just goes back up. All right, this is not a graph of the situation because we're not going to have a sharp curve. All right, and then look, is there anything else here? No, the next 2 derivatives are about concavity. So,
I'm having a hard time telling which one is f prime and f prime.
Yeah, if I make it a little bigger, do you guys? Okay, so these are both double derivatives, the next ones, okay? So if I go back to a entire page. Now, this says it is concave down from 0 to 1. Okay, concave down, right? Now again, I'm going to erase the purple here in a second. Then what does it say? And when it's greater than 4, 2, 3, 4. So it's saying that it's concave down here in these 2 spots. I'm just drawing a little curve so I kind of see it. Then it's saying what? It's concave up between 1 and 4. And we'll deal with the limit last. 1 and 4, it's saying it's concave up. Okay? It's pretty easy to see when you kind of mirror the black in here. And I'm going to get rid of the black. I'm going to do the curve up higher and then move it down. So it goes like this. And then we're going to have to deal with what happens at the end. So that's the curve. And that's handled. Not only that, it's handled all this stuff in purple, the concavity. All right, so I get rid of all the purple and all the stinking black, right? And I get, and someone here says, well, Anderson, I'm not going to do it that way. You figure out your system, all right? Concave down, concave up. And everyone, I read this. The limit as x goes to infinity approaches 1. So at 1, we have a horizontal asymptote, right, of 1. That's the graph. Now, tomorrow, evens and odds could definitely be on the test. The last statement here says, is this an even or odd statement, this question? It says that the y value for negative x is the same as the y value of the positive x. It is an even function. Yeah, you only had 2 choices. You suck. All right, here we go. I love you too. All right, so listen. There it is. I just grabbed. Oh, and let's get rid of this curve. This is not on there, right? That was just transportation. And there's our graph. And it should approach this same one there. So that's a good sketch. Everyone, what if the next question said, tell me the global min of the graph you drew? -1. Guys, the global min is -1. Where does it occur? 2 spots, 2 and -2, because of this. All right? All right, everyone. Keep practicing. this is definitely on Mr. Anderson's chapter 4 test.